Today we're going to do 1.3 day 2 and we're going to talk about absolute value equations. Let's start with the example of x plus 4 equals 8 and x plus 4 equals negative 8. And we are going to solve and graph. So let's start by solving. I'm just going to take x plus 4 equals 8 and I'm going to add a negative 4 to both sides to get x equals 4. Then I'm going to do the same with the other one of x plus 4 equals negative 8. Again, I'm going to add a negative 4 to both sides to isolate that value. And in this case, I get x equals negative 12. So after I've solved, now I need to graph. So we're just going to make a number line, and I'm going to put 0 at the middle. And then I'm going to put my two values of 4 and negative 12, but I need to be aware of that they're not equally distant from 0. So I'm going to put 4 about here and negative 12 to the left, but a little farther. At each of those points, I'm going to make a dot at them to show that's where they would fall on the number line. I would like for you to try the next one in your small group. You're going to solve and graph. So again, I want you to take 2x plus 3 equals 7 and 2x plus 3 equals negative 7. I want you to solve them in your small group and then graph them. So go ahead and pause the video and take 2 minutes to do that. Okay, so what you should have done is we're trying to isolate x. So I'm going to first start by adding a negative 3 to both sides. And I get 2x equals 4. I'm then going to divide by 2 and get x equals 2. On the second one, again, I'm going to add a negative 3 to both sides. Again, I'm isolating that variable, so I'm going to get 2x equals negative 10. Finally, we're going to divide by 2, so x equals negative 5. Then I'm going to make my number line. Again, I'm going to put 0 down. And I'm only going to do 2 and negative 5, but I have to be aware that they are not equally distant from 0. So I'm going to make negative 5 be a little bit farther than 2. And then at both of those, I'm going to put a dot because that's where they fall. I would like for you now to turn to page 15 in your record and practice journal. We are going to do our notes for the rest of the day from there. Let's start with example 1. It says the absolute value of x equals 3. So all we're going to do is just like how you had two equations before, we need to create two equations. These bars are really great clues that since you have two bars, you should have two equations. The first one I'm going to do is just x equals 3. The second one I'm going to do is x equals negative 3. You only change what's after the equal sign. Now let's just graph them because x is already isolated. So at the middle I'm going to make a 0. These can be equally distant. I can make a negative 3 and a 3. And at each point I'm going to, or at each 3 and negative 3 I'm going to put a dot to show that's where they fall. We're going to try number 2 together. Okay, so we're going to try the absolute value of x minus 4 equals 1. So remember the absolute value is just your distance from 0. So I'm going to make my first equation. I'm going to do exactly how I see it. But I'm going to get rid of the absolute value and make this x minus 4 equals 1. In my second equation, I'm going to keep x minus 4 the same. And I'm just going to change that to a negative 1. And solve like normal. So go ahead, pause the video and in your small group, solve and graph. Alright, so what you should have done is added 4 to both sides. And in the first equation, you get x equals 5. And in the second equation, you get x equals 3. So I'm going to make my number line. Again, I'm going to do 0. This time I'm going to do 3. And then 5, and at each point I'm going to make my dot. So let's try another one. I want you to try number 5 in your small group. First, I want you to take 30 seconds and pause the video to create the two equations. Then play the video to see what to do next. Okay, so what you should have came up with is 3x minus 2 equals 10 and 3x minus 2 equals negative 10. If you did not get that, go ahead and fix it. Now I want you to pause the video again and solve and graph the solution. Alright, so what we should have done first is added 2 to get 3x equals 12. Divide by 3, so x equals 4. On the other side, I'm going to do the exact same thing by adding 2. And this time I get 3x equals negative 8. Divide by 3. So x equals negative 2.6. And you can leave it as a fraction if you want, or you can write it as a decimal. Finally, we need to graph. So again, I'm going to do 0. I'm going to do 4, and then I'm going to do negative 2.6 a little closer because it's closer to 0 on the number line. And that at each one, I'm going to make a point, and there is my answer. Okay, the next one I want to look at is number 6, the absolute value of 5x minus 2 equals negative 10. Now remember, absolute value is your distance from 0. Can you ever run a negative distance? The answer is no. You can never run a negative distance. So if you have absolute value that's all alone like it is here, and you have a negative value, your answer is no solution. Because it's already negative, so therefore it can never happen. Okay, turn to page 16 in your record and practice journal. Let's try this next example, number 7. The absolute value of 2x plus 5 minus 5 equals negative 2. Now the difference in this example is negative 5 is attached to the absolute value, but it's not inside of it. As in the previous examples, the absolute value is all alone. So before we can break up our equation, we must get absolute value alone. So this just means absolute value, the AV. So what I'm going to do is I'm going to add 5. We could do SAO there, and I'm going to add 5 to both sides to make this the absolute value of 2x plus 5 equals 3. At this point, absolute value is alone. Now we can break it up into our two equations. So take 15 seconds and see if you can create the two equations. You should have come up with 2x plus 5 equals 3 and 2x plus 5 equals negative 3. Now I want you to pause it and take about a minute and a half and solve and graph in your small group. Okay, so I'm going to add a negative 5 to both sides to get 2x equals negative 2. Divide by 2, so x equals negative 1. On the other side, again, I'm going to add a negative 5 to get 2x equals negative 8. Divide by 2, and x equals negative 4. On my graph, I'm going to put 0, negative 1, and negative 4. And at each point, or at each one of those two locations, I'm going to make a dot. I want you to try number 8 in your small group. Okay, so here's the start to number 8. And before you get started, my clue is, what does it mean when 3 is written right next to the absolute value? Notice there's no plus or minus there, so what would be your first step? See if you can try it on your own in about 20 seconds. Go ahead and play the video to see if you got it correct. Okay, so what you should have done is divided by 3. And then your equation is the absolute value of 4x plus 6 equals 8. Now go ahead and create your 2 equations, solve, and then graph on your own. Alright, so you should have came up with 4x plus 6 equals 8, and 4x plus 6 equals negative 8. I'm going to add a negative 6 to both sides to get 4x equals 2. Divide by 4, so x equals 1/2. I'm going to do the same thing on the other side. So I get 4x equals negative 14. Then divide by 4, and x equals negative 3.5. Last, I'm going to make my number line. I'm going to put 0, I'm going to put 1/2, and negative 3.5 just a little farther. And at each of those, I'm going to put a dot to show where they would fall. The last one I want you to try is number 10. Now remember order of operations of trying to get your absolute value alone. Now some of you might be thinking, okay, Miss Summers, this is no solution because it equals negative 17. But you first need to get absolute value alone. Since it's not isolated, we need to move the negative 5 and the 3. So remember, we work in reverse of order of operations. So I'm going to start by adding a negative 3. So my new equation is negative 5 times the absolute value of x plus 3 equals negative 20. Now you might still be thinking, okay, it's still negative, so it's no solution. But again, look, is absolute value fully alone? No, we still have this negative 5 written right next to absolute value. So we're going to divide everything by negative 5. So my new equation is the absolute value of x plus 3 equals 4. Now your absolute value is alone and it equals a positive. So from this point, since this is isolated and it's all by itself, we can make our 2 equations. So I'm going to have x plus 3 equals 4. X plus 3 equals negative 4. And we're going to solve. I'm going to add a negative 3 to both sides to get x equals 1. And on the other one, I get x equals negative 7. I'm going to make my number line 0, 1. Again, I'm going to move negative 7 a little bit farther. Place my dot, and I am done. So what I would like for you to do is I would like for you to start working on day 6, which is in your textbook. It's going to be page 24 to 25, numbers 1 through 8 all. So I want you to get started. If 1 or 2 people have their textbook at their table, you can open that up. Or one of you can sign into Big Ideas on the computer and project the textbook onto the screen. Make sure you log out before you leave class. This is due on Monday, as well as quiz corrections, so make sure you get those done as well. This video will also be posted on Edline for you to watch over the weekend in case you need to do it. I hope you guys have a great weekend, and I will see you on Monday.